So next example, find the point. So you're starting to get used to, hopefully, this type of direction. It says, find the point in the interval -1, 1, the closed interval -1 to 1, -1 to 1, where the instantaneous rate of change of f of x equals x to the 2/3 power, if that's not clear, x to the 2/3 power, is equal to the average rate of change. I could say average rate of change over the interval. All right, so go ahead and try that. See what you find out. All right, so here's what we would do. So whenever we see instantaneous rate of change equals average rate of change, the first thing we're going to do is write f prime of c equals f of b minus f of a. And in a free response question, a lot of times, like just writing something like this already gets you a point for, the setup. So always try to write where everything is coming from and be really clear, complete, concise, and consistent statements. All right, so let's go ahead and find out what f prime of c is. Well, so f prime of x is going to be 2/3 x to the -1/3. So 2/3 c to the -1/3 power equals, let's see, so my b and my a are both 1. I guess I'll write this out. You don't have to write this out, but I usually do. A equals 1. B equals 1. A is -1, right? Here's A, here's B. A is -1, B is 1. Let's see, -1 to the 2/3 power. Well, that means I'm going to take -1. I'm going to do the cube root of it, and then I'm going to square that. So cube root of -1 is -1, but when I square it, I get +1. So f of A is +1. And then f of b is 1 to any power is always going to be 1. All right, so that's what I got. 1, 1, 1, 1. That's interesting. Yeah, right, okay, makes sense. Okay, so then I have 1 minus 1 over 1 minus -1. So that's 0 over 2, which is just 0, okay? So we don't need to, that doesn't blow us out of the water yet. It's just 0. So basically what it's saying is, I know that the average rate of change of the function is 0. That means that whatever f of a was and f of b was, they lie on a horizontal line. So all I need to do, this is what the secant line looks like. So the secant line looks like, -1, 1, 1. That's what the secant line looks like. So all I need to do is, I don't know what the graph looks like, but all I need to do is find anywhere in here that the tangent line is horizontal. And I mean, there kind of has to be such a point, right? So no matter what kind of weird thing I do in here, somewhere there's going to be a horizontal tangent. So that's really what I'm looking for, is where the derivative is equal to 0, where's the horizontal tangent? Maybe there's more than one. But, I just sketched that out. Is it possible to draw this so that there's no horizontal tangent? I don't know. How could I draw it that there would be no horizontal tangent? Anyway, we'll stop trying to guess the answer and figure it out. All right, so when I go to solve an equation, so here's another, I think I've mentioned this before. When I go to find derivatives, I like fractional and negative exponents because it works well with the power rule. But when I go to solve an equation, it's not obvious how to solve an equation with a c to the -1/3 power in it. So it's probably better for me to rewrite, when I go to solve the equation, rewrite my negative and rational exponents as roots and fractions. So I've got this, okay? Now, as soon as I see this, there's a sort of a basic algebraic idea with fractions equaling 0. So if I have some a of x over b of x, and that fraction equals 0, the only way that that can happen is that a of x is 0, and b of x is not 0, all right? So whenever I'm looking at a numerator and denominator equal to 0, if I want that to be equal to 0, then just the numerator has to be equal to 0, all right? So basically, this equation amounts to 2 equals 0, which has no solution. So in fact, there is no point between f of -1 and f of 1. There's no point in that interval where the tangent is horizontal. How could that be? How indeed, you ask? Well, I will show you what the graph looks like. All right. So what happens in the interval from -1 to 1 that I failed to anticipate in this little drawing? There's a what at 0, 0. there's a non-differentiable point. In fact, I can see that in the way that the denominator here is c. So if the denominator were 0, the derivative would be undefined. But I'm not looking for a point where f prime is undefined. I'm looking to be able to draw a tangent line that is parallel to the secant line. In fact, here's the secant line right there. Come on, secant line. There. That's the secant line. Okay? Do I ever have a tangent line that's parallel to that? No, because whenever x is less than 0, I can see that the tangent line is going to have a negative slope. In fact, f is decreasing. Whenever x is greater than 0, I have a positive slope. And there's no point here where there's a 0 slope, because at x equals 0, there's no tangent line at all. So we can't say that there's a 0 slope at x equals 0. So all negative slopes, all positive slopes, undefined slope, there's no place in this interval where the tangent line is parallel to the secant line. So no, there is no such point. So there is no such point. So our next question is going to be, how do I know? And by the way, though, we already have one hint. We know why. Because f has a non-differentiable point. That's what did it, right? That's what made us be unable to find a parallel tangent, a tangent parallel to the secant, because there was a non-differentiable point in the interval that we were talking about. Okay, so our next job is to really suss out exactly what kinds of functions and what kinds of intervals are going to have this magic point and which ones are not going to have the magic point. And that is what we'll look at next.